Hello friends and my dear students, I welcome you all to my channel. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I highly suggest and request that you subscribe to my channel, support me, and also please do not forget to press the bell icon so that you will be notified by my future videos. So this video is part of the playlist CBSE Mathematics Class 7 following the textbook of author RS Aggarwal. This is part 2 of the series of videos on the chapter Unitary method, where I will discuss about the inverse variation of two quantities A and B. In part 1 of this part 1 video on this chapter, I discussed about direct variation of two quantities A and B. If you have not watched that video, I highly suggest that you watch that video first to get a good concept and continuity of the chapter Unitary method. So once you are familiar with direct variation of two quantities A and B, then you can watch this video, and then finally I will solve problems from exercise 9b, which will be based on both the direct variation and inverse variation of two quantities. So let's get started with this video. Okay, so as usual, I have my rough notes prepared on the left hand side, and I will discuss any concept that I will discuss, and I will solve the problems on the right hand side. So this video is about two quantities that vary inversely or in inverse variation. So two quantities, please follow the notes on the left hand side. Two quantities A and B are said to vary inversely or in inverse variation if the product AB remains constant. So over here, the small a and small b are not actually values, they are actually representing some quantity that will have some value. Let's say the cost of a product. So the cost of a product. So the cost is actually so these these quantities A and B are representing those quantity like cost, or let's say the speed of a car, or time taken to travel a distance by a car. So these are those kinds of quantities. Now, so so if we have that, now it says that if the quantities A and B are if they vary inversely or they are in inverse variation, then their product always remains constant. Their product are same. So if A1 and B1 are values of the quantity A and B respectively, and also A2 and B2 are other values of A and B of the quantity A and B respectively, then we have A1 B1 equals to A2 B2, where the quantity A and B vary inversely. So it is saying that, so if A and B are the two quantity and they vary inversely, Now it is saying that if let's say A1 is a value of A1 and B1 are values of quantity A and B, and A2 B2 are some other values of the same quantity A and B, then this implies that A1 B1 will be equal to A2 B2. This is what it's saying. Okay, this concept that the quantity, the values of the quantity A and B, their product remains constant if the quantities A and B vary inversely. This can be explained, or this can be mathematically expressed in some other form, and it says that the ratio of any two values of the quantity A is equal to the inverse ratio of the corresponding values of quantity B. So in this case, so A1 and B1, A1 and A2 are two values of the quantity A, and B1 and B2 are the corresponding values of quantity B. So the ratio of the values of quantity A is A1 is to A2, and the ratio of the values of the values of quantity B is B1 is to B2. Now it is saying that the ratio A1 is to A2 will be equal to uh, the inverse ratio of B1 is to B2. Now what is the inverse of a ratio? I mean, if there is a if x is to y is a ratio, if x is to y is a ratio, if you take its inverse, if you consider the inverse ratio of x is to y, it will be y. It is nothing but y is to x, that you interchange the terms. So y is to x is the inverse ratio of x is to y, and conversely x is to y is the inverse ratio of y is to x. So it is saying that for the two quantities A and B, if they vary inversely, and if A1 and A2 are two values of A, and B1 and B2 are the corresponding values of quantity B, then the ratio of the two values of quantity A, that is A1 is to A2, will be equal to the inverse of the ratio of the ratio of the corresponding values of quantity B, that is B1 is to B2. Now inverse of B1 is to B2 is nothing but B2 is to B1. Now if you have this implies that A1 by A2 equals B2 by B1. Now this implies if you do cross product, we get A1 B1 equals to A2 B2. This is the same result that we explained earlier. So A1 B1, that is the values of the quantity A and B will always remain constant, where the quantity A and B vary inversely. So this is the basic concept of two quantities that vary inversely. Now some examples could be, consider a car running at a constant speed, which is running at a uniform speed, that is once it starts moving, its speed does not change. That is meant by a car moving at a uniform speed. So consider a car covering a certain distance. So it will run at a specific speed, and it will cover the distance in a specific time. So here speed and time, these two quantities they vary inversely. That is, if you increase the speed, time taken will be less, and if you decrease the speed, time taken will be more. So you can understand that if two quantities vary inversely, so if the quantities A and B vary inversely, then more A will imply less B. Sorry, it's more of A will imply less of B, and less of A will imply, since the product is constant, so if you increase A, B has to decrease, and if you decrease A, B will increase. So this is the concept. So speed and time of a car covering a certain distance and running at a uniform speed is an example of, so here speed and time vary inversely. Another example is a number of men engaged to complete a specific task, and the number of days to complete the specific task. So here number of men and the days to complete a specific task are vary inversely. So if you engage more men, then less number of days will be required to complete a task, and if you engage less number of men, then more number of days will be required to complete the same task. Okay, so this is all about the concept of two quantities that vary inversely. The main thing, while solving the problem, the main concept that we need to understand is that we have to understand that the quantities, whether the quantities are vary inversely or they vary directly, and accordingly we will apply the formula. So in the previous video, I explained about, discussed about direct variation. So if two quantities A and B are in vary directly, that is, they are in direct variation, then their ratio or remains the constant. That is, A by B or B by A remains constant. And in this case, when the two quantities vary inversely, their product remains the same. So these two concepts will be required to solve the problems of exercise 9b. So now let's start solving the problems of exercise 9b. I will try to solve all the problems. I guess there are 12 problems. Let's see. Now, if you wish to take a screenshot of the notes, you can pause the video and take a screenshot, because I will minimize this PDF, and I will have to see open the exercise problems of the exercise 9b. Now you can take a screenshot of the notes. Okay, let's start solving the problems from exercise. I'm not sure whether you will be able to see it. Let's may increase the font a little bit. Okay, so the first question says that if 48 men can dig a trench in 14 days, how long will 28 men take to dig a similar trench? So the task is to dig a trench, and some men are working to dig a trench, and the problem is about men digging a trench in certain number of days. So we can, as I have explained as an example over here, the number of men and the number of days to dig a similar trench, these two quantities are in inverse, they are vary inversely. So it is given that 48 men takes 14 days to dig a trench. It is asking how long will 28 men take to dig a similar trench. So let's say 28 men will take X days to dig the similar trench. So we have two values. So quantity, so number of men is you can consider number of men as the quantity A, and the number of days to complete to dig the trench as the quantity B. So over here you have the values of the quantity A and B. You get 48 and 14, and for the second you have the values of the quantity A and B, where A is here the number of men, and B is the quantity B is the number of days required to dig the trench. So in the second case, we have the data, we have the values 28, x. So now we know that the product of, we know that A1 B1 will be equal to A2 B2. So 48 into 14 will be equal to 28 into x. So this implies x equals 48 multiplied by 14 divided by 28. This is 2, this is 24, this is 24. So x 24 days. Now you can clearly see that 48 men was digging the trench in 14 days, and now if you decrease the number of men, that is 28 men, definitely they will take more days. So 28 men are taking 28 days, 24 days. Okay. Let's see question number 2. It says 16 men can reap a field in 30 days. how many men must be engaged to reap the same field in 24 days. So it's the same kind of work, same kind of problem, that is men at work. The men are doing some task. Over in the problem 2, the task is to reap a field, and the quantities here are a number of men. The quantities A and B in this problem are the number of men and the number of days. So it is given that 16 men is taking 30 days to reap a field, and it is asking how many men must be engaged to reap the same field in 24 days. So let's say X men need to be engaged to reap the same field in 24 days. So now therefore we know that the values of the quantity A and B, their product remains constant. So we can say that 18 into 30 will be equal to 24 into X. 16 into 30 will be equal to actually X into 24. This implies X equals 16 into 30 divided by 24. This is 4, 6, 4, 4, 6, 6, 5. So 20 men will be required to reap the field in 24 days. Now you can see that 16 men was taking 30 days to reap the field, and if you want to reap the field in less number of days, you have to engage more men. So we are having 20 as the answer. So 20 men will be required to reap the same field in 24 days. So over here in the first information, that the values of the quantity A and B are 16, 3, where the quantity A in this problem is the number of men and the quantity B is the number of days to reap the field, and in this case it was say X, 24. Now in this bracket, what I mean, the two values in this bracket, I mean that this is A1, B1 and this is A2, B2. So A1 is a value of the quantity A and its corresponding value of the quantity B is B1. Similarly, just for your understanding, I am writing this A1, B1 and this is A2, B2, and we know that A1, B1 will be equal to A2, B2. Okay, let's do problem number 3. Problem number 3 says that 45 cows can graze a field in 13 days. How many cows will graze the same field in 9 days? So it's a similar kind of problem, just that instead of men we have cows. So it is 45 cows requires 13 days to graze a field, and it is asking how many cows will graze the same field. Let's say X cows will graze the same field in 9 days. So in this, the quantity A is the number of cows and the quantity B is the number of days required to graze the field. Now, so therefore we have the product will be equal. So we have 45 into 13 equals X into 9. From here we can say that X equals 45 into 13 divided by 9. This is 65. So definitely, if you need to graze the field in less number of days, that is 9 days, which is less than 13, you have to engage more cows, more than 45 cows. So the answer is 65. So while I am solving the problem, you can pause the video and take screenshot for your future reference. So over here we have 45, comma 13. This is the values of A1 and B1, and here we have x comma 9. This is the value for another values of the quantity A and B, and in this case the quantity A is the number of cows and the quantity B is the number of days required to graze the field. Okay, let's do problem number 4. It says 16 horses can consume a certain quantity of corn in 25 days. 16 horses can consume a certain quantity of corn in 25 days. Okay, in how many days would the same quantity be consumed by 40 horses? So the quantity of corn consumed is constant. So if that is constant, then definitely more horses will consume the same quantity of corn in less number of days, and less number of horses will take more days to consume the same quantity of corn. So we can clearly see and understand that the two quantities in this problem are number of horses and the number of days to consume a certain quantity of corn, and they vary inversely. So it is given that 16 horses takes 16 horses take 25 days to consume a certain quantity of corn, and in how many, it is asking in how many days would the same quantity be consumed by 40 horses. So let's assume that 40 horses will take x days to consume the same quantity of corn. Now we will have, so over here the values of the quantity A, in this case the quantity A is the number of horses and the quantity B is the number of days required to consume a certain quantity of corn. So this is 25. 16 is the value of the quantity A and 25 is the value of the quantity B, and in this case it is 40 x. This thing I am writing just for your understanding. This is definitely not a part of the solution or steps of solving the problem. Okay, so now we know that A1 B1 will be equal to A2 B2. So 16 into 25 should be equal to x, should be equal to 40 into x. This implies x equals 16 into 25 by 40, and this is 4, 10, 4, 4 and 5, 2, 5, 5, 2, 2, 2. So this is x. So x is 10 days. So definitely if you engage more horses, more number of horses will take less number of days to consume the same quantity of corn. Okay, let's do problem number 5. No, it is too big. Okay, problem number 5 says a girl can finish a book in 25 days if she reads 18 pages of it every day. Okay, so every day if the girl reads 18 pages, she can finish reading a book in 25 days. Now, how many days will she take to finish it if she reads 15 pages every day? So the quantity, the two quantities in this problem, we have to first identify the two quantities of the direct which are we have to identify the two quantities given in the problem and whether they vary inversely or directly. So in this problem, the two quantities are number of pages read every day number of pages read every day. So I am just for your reference, the quantity A is referring to number of pages read every day, and B is referring to the number of days required to finish the book, that is finish reading the book. So these are the two quantities. Quantity A, I am assuming a quantity A, I am referring quantity A to be the number of pages that is read every day by the girl, and the quantity B to be the number of days required to finish the book. So clearly we can see that the quantity A and B vary inversely, because if you read more number of pages per day, then definitely you will take less number of days to complete the book, and if you read less number of pages per day, you will take more number of days to complete the book. Okay, and now the data given is that 18 pages, if 18 pages is read per day, then the book is finished in 25 days. And and the question is, how many days will she take to finish the book if she reads 15 pages every day? So if she reads 15 pages every day, let's say she finishes the book in X days. So over here 18, 25 are the values of A1, B1, where A is the quantity number of pages read every day and B is the quantity number of days required to finish the book. Over here we have 15, X. This is refers to the value, another values of the quantity A and B. So now we must have A1, B1 equals to A2, B2. So 18 into 25 should be equal to 15 into X. This implies X equals 18 into 25 divided by 15. This is 6, 5, this is 30. So definitely 18 pages, if the girl was reading 18 pages and she was completing the book in 25 days. Now if she reads less number of pages per day, that is 15 pages, then definitely she will take more than 25 days, and our answer is 30. So it is fine. So the girl will complete the book in 30 days if she reads 15 pages per day. Okay, let's solve question number 6. Question number 6 says that Rita types 40 words per minute and takes 24 minutes to type a certain document. Her friend Geeta has a typing speed of 40 words per minute. Her friend Geeta has a typing speed of 40 words per minute. Okay. In how much time will she be able to type the same document? Okay. So Rita types 40 words per minute. Rita types 40 words per minute and takes 24 minutes to type a certain document. Now it is very, very crucial and very, very important to identify the quantities which are the quantities which are varying, either directly or indirectly. Only then we will be able to solve the problem. Now in this problem there are certain quantities mentioned. One is number of words typed per minute. That is one quantity this talking about, and another quantity is total number of minutes total number of minutes taken to type a certain document. So for Rita, now for Rita types 40 words per minute. So her typing speed is 40 words per minute, and she completes typing a document in 24 minutes. Now the document is same. The document concerned in this problem is same. So it is asking then, if another person Geeta has a typing speed of 48 words per minute, how much time will she take to type the same document? So if the typing speed is more, so here the two quantity data concerned are typing speed, which is number of words per minute, and the other quantity is total time taken to type a certain document. So if the typing speed is more, that is if you type more words per minute, definitely you will take less amount of time to type a certain document, and definitely if your speed is less, then you will take more time to type the same document. Okay, so over here, just for clarity, the quantity A is words typed per minute. This is the first quantity, and the second quantity is time taken to type a document. So A is the typing speed, which is words typed per minute, and B is the total B is the total time taken to type a certain document. Now, for the first data given is for Rita, it is if it is given that Rita types 40 words per minute, that is the value of A is 40. So 40 words I am writing as words per minute, I am writing it as W/M. So with a typing speed of 40 words per minute, time taken is 24 minutes. 24 minutes time taken to type a document is 24 minutes. And it is asking regarding Geeta, if Geeta has a typing speed of 48 words per minute, then how much time she will take to type the same document. Let's say she will take X minute. So over here 40 comma 24 is the value of A1 B1, and over here 48 comma X is the value A2 B2. So clearly we have that A1 B1 equals to A2 B2. So 40 into 24 will be equal to 48 into X. 48 into X. Okay. So this implies X equals 40 into 24 divided by 48. So this is 20. This is 20. So Geeta will take 20 minutes to type the same document with a typing speed of 48 words per minute, which is quite meaningful, because if Rita is taking 24 minutes to type the document with a typing speed of 40 words per minute, and Geeta has a more typing speed, his typing speed is more than Rita, so definitely she will take less time. So our answer is 20, which is less than 24 minutes. So answer is 24 minutes. 20 minutes. In 20 minutes, Geeta will complete will finish typing the document where she is typing at a speed of 48 words per minute. Okay. Let's do problem number 7. A bus covers a certain distance in 3 hours 20 minutes at an average speed of 45 km per hour. How long will it take to cover the same distance at a speed of 36 km per hour? So this is regarding the speed and time that I explained as an example while discussing the concept of inverse variation. So the bus is to cover a certain distance. The distance over here is fixed. To cover a certain distance, it says that the bus takes 3 hours 20 minutes to cover the distance when it is running at a average speed of 45 kilometer per hour. So it is given that, so over here a, the quantity, let's say a is speed of bus. Let's say the quantity b, the time taken to cover the distance. Here distance is fixed. The distance is fixed. So we are considering the A as the speed of the bus, which is in kilometer per hour, and B as the time taken to cover a certain distance running at a given speed. So the first data we have is, so 45, when the bus is running at 45 kilometer per hour at a speed of at an average speed of 45 kilometer per hour. Now average speed is average speed means the speed is constant. When the bus is running, it is maintaining it. Average speed is also means the uniform speed. So it is running, its speed is constant. That is, it running always at a speed of 45 kilometer per hour. So when the speed is 45 kilometer per hour, the time taken to cover a certain distance is 3 hours 20 minutes. Now the question has asked how long will it take to cover the same distance at a speed of 36 kilometer per hour. Let's say it takes x minute. Now we have to convert this 3 hour 20 minutes to a single unit, to minutes. Now this is equal to 3 into 60 plus 20, this is 200 minute. So this is 200 minute. Okay, so now we can say that since the A1 B1 will be equal to A2 B2, over here 36 comma x is the values of A2 B2, and over here there is no space, 45 comma 200 is the values of A1 comma B1. So therefore we must have 45 into 200 should be equal to 36 into x. X we have assumed to be in minutes. So we had to convert 3 hour 20 minutes in minutes, which is equal to 200 minutes. Now this implies x equals 45 into 200 divided by 36. This is 9495, and this is 50. So this is 250. So 250 minute. So if the bus is traveling at a lesser speed, that is 36 kilometer per hour, it will definitely take more time. Earlier it was running at 45 kilometer per hour, and it was taking less time, it was taking 200 minutes. Now if it runs at 36 kilometer per hour now, which means it is running at a less speed, it should take more time. So it is now taking 250 minutes. So the answer is 250 minute. Now you can convert this 250 minute to hour and minutes. This is equal to this is equal to 3 hour, not 3 hour. This is equal to 4 hour and 10 minute. Yes, 4 hour and 10 minute. Okay, let's do problem number 8. Problem number 8 says, at the beginning of a month, a factory has enough materials to make 240 tons of steel in a month. At the beginning of a month, a factory has enough materials to make 240 tons of steel in a month. Okay. If 60 more tons of steel is to be made that month, uh, how long will the materials last? The language is a little complex. Let's try to understand the language. It says that at the beginning of a month, a factory has enough materials to make 240 tons of steel in a month. If 60 more tons of steel is to be made that month, how long will the materials last? If 60 more tons of steel is to be made that month, 60 more tons of steel is to be made that month, how long how long the materials will last? Materials last. So in the first case, it is saying that the materials lasts for a month, so that it can produce 240 tons of steel in a month. So in a month, the factory is producing 240 tons of steel, and the material is lasting for a month. Now, if more tons of steel is to be produced in a month, so the time is fixed, month is fixed in a month, then how long will the materials last? So the quantity is basically 60 more tons. So one quantity is number of tons of steel that is being produced in a month, and the other quantity, uh, how long will the materials last? How long will the materials last? So in the first case, at the beginning of a month, a factory has enough materials to make 240 tons of steel in a month. So at the beginning of the month, it has just enough materials that will produce 240 tons of steel in a month. Now, if more steel is to be produced, definitely uh, more materials will be required. More materials will be required, but more materials will be required. If 60 more tons of steel is to be made that month, 60 more tons of steel, that is 300 tons of steel is to be made, then more materials will be required. Uh, if 300 tons of steel is to be made in a month, then more materials will be required. But it is saying that it is asking how long the materials will last. How long the materials will last. Uh, okay, so amount of steel produced, so the quantity, it's the challenge is to identify the quantity that we need to consider that are varying directly or inversely. Now, quantity, amount, let's say A amount of steel produced in a month. This is the amount of steel, let A be the amount of steel produced in a month, and how long will the materials last? So the material is fixed. The material is fixed. And B could be uh, time, not time, duration for which the materials last. So if A is the amount of steel to be produced in a month, and if B is the duration for which the materials last, so if you increase the amount of steel to be produced in a month, then definitely more materials will be used, will be used, and so it will be more materials will be used, uh, and more materials will be used, and the materials will not last for a month. Will not last for a month. So if you increase A, the amount of steel to be produced, B is the duration for which the material lasts, B will decrease. Okay, and if you decrease the amount of steel to be produced, then definitely the materials will last for a longer time. So B will increase. Okay, so A and B in this case are in inverse. They vary inversely. They vary inversely, but we need to also consider the data given. In the first case, how long will the in question number 8, how long will the materials last? How long will the materials last? So in the first data, if you consider it is saying that to produce 240 tons of steel in a month, the factory has enough materials. Okay, so it is so the materials is lasting for 1 month to produce. So in producing 240 tons of 240 tons of steel, the materials is lasting for 1 month. Is lasting for 1 month. Now, to produce 60 more tons, that is 240 plus 60 is 300 tons, 1 month. So let's since to produce 300 tons of steel, the materials will last less than a month, so it will be in days. So let's convert the unit 1 month to days. So this is 30 days. So this is 30 days. Now 300 tons, let's say, assume that 300 tons, to produce 300 tons in a month, the materials will last, let's say, X days. Say X days. So 240 comma 3 is the value of A1 and B1, and over here 300 comma X is the value of A2 and B2. So I hope you understood that the two quantities that we need to consider in this problem is A is the amount of steel that is being produced in a month, and B is the duration for which the materials is lasting to produce A amount of steel in a month. So in the first case, in the first information, it says that uh, the factory has enough materials to produce 240 tons of steel in a month. So it means that to produce 240 tons of steel in a month, the materials is lasting for a month. So 1 month 30 days. So we have 240 tons is being produced. To produce 240 tons of steel, 30 days is the lasting time of the materials. Now it is asking how long will the materials last if we have to produce 300 tons of steel in a month. So that we have assumed X number of days, the materials will last X number of days if 300 tons of steel need to be produced. Okay, so now we can say, as per the two quantities, if they vary inversely, we know that A1 B1 will be equal to A2 B2. So we can say that 240 into 30 will be equal to 300 into X. This implies X equals 240 into 30 divided by 300. This is 10, this is 24. So 24 days. Definitely, obviously, if we have to produce more tons of steel, then the materials will last lesser number of days. So earlier, in the previous case, when it was producing 240 tons of steel, the materials was lasting 1 month, which is 30 days. And now if we have to produce 300 tons of steel, which is more in a month, then the materials will last for 24 days. So answer is 24 days. Okay. Let's solve question number 9. It says that a contractor employed 210 men to build a house in 60 days. Okay. After 12 days, he was after 12 days he was joined by 7 more men. In how many days will the remaining work be finished? A contractor employed 210 men to build a house in 60 days. Okay, so the quantity involved are basically the number of men and number of men engaged to build a house. Let's say let's identify the quantity A and B in this problem. Let's say A, B, number of men employed to build a house, and B the let's say number of days required to build the house. So definitely if more men are employed, then less number of days will be required to build the house. And the first data information it gives that it has given that 200 men is building the house in 60 days. So it says that a contractor employed 200 men to build a house in 60 days. A contractor employed 210 men to build a house in 60 days. After 12 days, a contractor employed 210 men to build a house in 16 days. In 60 days. After 12 days, he was joined by 70 more men. In how many days will the remaining work be finished? Now, it is not clearly saying that 210 men is required to build a house in 60 days. It just says that a contractor has employed 210 men to build a house in 60 days. And after 12 days, he was joined by 74 men. And hint is given 200 men can complete the remaining work in 48 days. 210 men can complete the remaining work in 48 days. Find in how many days 280 men can do it. Find in how many days 280 men can do it. 210 men can complete the remaining work in 48 days. Okay, so the hint given is that after 12 days, definitely 48 days will be remaining. So the remaining, whatever work has been done in the first 12 days, the remaining work will be done by the 210 men of the remaining work will definitely be done in 48 days. Now, after 12 days, he was joined by 74 men. In how many days will the remaining work be finished? Now we have to somehow identify the remaining work. Remaining work. So in 12 days, so by the contract, the 210 men employee should complete should build the house in 60 days. Now in 12 days, these 210 employed men has already done some work. So ideally, in the remaining 48 days, these 210 men should complete the remaining work in 48 days. Okay, so that is why the hint is given like that. So now we have to consider the remaining work. So it is asking then in how many days will the remaining work be finished. Now we have to concentrate our focus in the remaining work. So as per data, the remaining work should be completed in 48 days. Now it's all about the remaining work, not the complete work to build the house, the remaining work. So after 12 days, the 210 men has done some work and they are supposed to do the complete work, that is to build the house in 60 days. So definitely in the remaining 48 days, these 210 men is supposed to complete the remaining work. So 210 men now, this is all about remaining work, not the complete job of building the house, the remaining work. So now we have the information that 210 men it was supposed to complete the house remaining work in 48 days. Why 48? 60 minus 12. So 48 days. Now after 12 days 70 more employee have joined. So we have now 280 men will complete this remaining work in how many days? That is the question. So let's say in X days. So now we have this 210 men is completing, will take 48 days to complete the remaining work. This is about the remaining work. Remaining work, RW. So the question now is asking that after 12 days, when 70 more men have joined, it becomes, the total number of men becomes 280. Now, in how many days will the remaining work be completed by these 280 men? Where we know a fact that 210 men will complete the remaining work in 48 days. Okay, so 210 and 48 is the data for A1, B1, where we have to change the definition of A and B, and 280 comma X is the value of A2 comma B2, where A is the number of men employed, that is fine, but B is the number of days required to not build the house but to complete the remaining work. That is the work that is in 12 days, in the first 12 days, the 210 men has already done some work, that is in building the house. So some work is left. So that is what is meant by to complete the remaining work. So therefore, we will have A1 B1 equals to A2 B2, that is 210 multiplied by 48 will be equal to 280 multiplied by X. This implies X equals 210 multiplied by 48 divided by 280. Okay. 7 4 7 3 4 1 2. So this is 36. So in 36 days, the remaining work will be completed by 280 men. So 36 days is the answer, which is quite obvious because 210 men was supposed to complete the remaining work in 48 days. Now you have more number of men, that is you have 280 men. So definitely the remaining work will be completed in less number of days than 48, which is 36 days. Okay, let's do problem number 10. It says a military camp has provisions for 630 men to last for 25 days. I guess to last for 25 days means provisions means food, I guess. So a military camp has provisions for 630 men to last for 25 days. Now, how many men must be transferred to another camp so that the food lasts for 30 days? So definitely if the food has to last for 30 days, then the number of men, the number of men has to be less, which means some men has to be transferred somewhere else. Okay, so over here, number of military men, and B is number of days that can serve the men. That can serve the men. Uh, okay, so definitely we can see these two quantities are in inverse proportion, because if there are more number of men, since the food is constant, if you have more number of military men, the food will last for less number of days, and if there are less number of military men, the food will last for more number of days. Okay, so one information it has given is that 630 men is lasting for 25 days. 25 days, and it is asking that how many men must be transferred to another camp so that the food lasts for 30 days. So instead of finding how many men need to be transferred, let's say X men uh, is can be served by the same food in 30 days. The food amount of food is constant, that is not changing. So let's say X men will be served in 30 days. Now definitely X will be less than 630, and then we will find the difference of 630 and X, which will be the number of men that need to be transferred. So 630 and 25 is corresponding to the values of A1, B1, and over here X comma 30 is the value of A2, B2. So therefore we know that since these two quantities are in inverse proportion, inverse variation, the product will be constant, that is A1 B1 will be equal to A2 B2. So this means 630 multiplied by 25 will be equal to X multiplied by 30. This implies X equals 630 multiplied by 25 divided by 30. This is 21. This is 21 into 25. 21 into 25. This is 525. So 525 men will be served in 30 days. So definitely men to transfer is 630 minus 525. This is 105 men need to be transferred to another camp. Okay, let's do question number 11. It says a group of 120 men had provisions for 200 days. After 5 days, 30 men died. After 5 days, 30 men died due to epidemic. How long will the remaining food last? This question is similar to question number 9. Question number 9. So it says that a group of 120 men had provisions for 200 days. Okay, meaning the food to keep survive 120 men will last for 200 days. Okay, now after 5 days 30 men died due to epidemic. After 5 days 30 men died due to epidemic. So after 5 days the scenario is we are having 90 men. We are having 90 men, but some food has already been consumed by the 120 men. Now after 5 days 30 men died. So the scenario after 5 days is that uh, after 5 days some food has been consumed. Now whatever food is remaining, whatever food is remaining uh, in that food, uh, uh, in that food will help to keep alive 120 men for 195 days. How long will the remaining food last? How long will the remaining food last? Remaining food, okay, remaining food. So now we have to consider the remaining food. Now, okay, so over here, let's identify the quantity that B, that A, B, mm, number of, A be the number of men, A be the number of men, and B be the number of days that can serve the men by the remaining food. Now, since it says that 120 men can survive, whatever the food is, in that food, 120 men can survive 200 days. Now, after 5 days, definitely these 120 men have consumed some food. So, the food that is remaining, in that remaining food, we know that 120 men will survive in that remaining food for how many days? 195 days, because 5 days have already gone. After 5 days, some food has been consumed, and if there is no death, we know that these 120 men will survive for another 195 days, because it says that 120 men had provisions for 200 days. So after 5 days, if there is no death, then the 120 men will survive for another 195 days on the remaining food. Please keep in mind that we are now talking about, we are having the data based on the remaining food. So after 5 days, this is all after 5 days. After 5 days, whatever food is remaining, based on the remaining food, 120 men can last for 195 days. Now, it has asked, now it says that 30 men died. This means 120 minus 30, which is 90. After 30 men died, then 90 men remaining, how long will they survive? So let's say they will survive for X days. Or, I mean, the question is how long will the remaining food last, which actually means, in other words, that for how many days the men will survive. So 120 comma 195 corresponds to the data A1 comma B1. Remember that A is the number of men and B is the number of days that can serve the men, that is A number of men by the remaining food. So this is 90 comma X corresponds to the value of A2, B2. Now we clearly know that A and B, these quantities are in inverse they vary inversely, that is they are in inverse variation, and so we will have A1 B1 equals to A2 B2, that means 120 multiplied by 195 should be equal to 90 multiplied by x. This implies x equals 120 multiplied by 195 divided by 90. This is 3, 3, this is 4, and this is 65. So this is 20 and 260. So after 5 days, 30 men died. Then the remaining 90 men will survive for 260 days based on whatever food is remaining. Okay. Let's solve question number 12. Now this question was similar to question number 9, and this question, question number 9 and this question number 11 was tricky. So that's the reason a hint was given. Okay, question number 12. It says that 1200 soldiers in a fort had enough food for 28 days. 1200 soldiers in a fort had enough food for 28 days. After 4 days, some soldiers were transferred to another fort, and thus the food lasted for an extra 32 days. So how many soldiers left the fort? Okay, how many soldiers left the fort? Okay, so 1200 soldiers can survive for 28 days based on whatever food they had. Now after 4 days, some food might have already been consumed by the 1200 soldiers. So let's identify the quantity A and B. Let A be number of soldiers. A be the number of soldiers, and P the number of days the soldiers survived or the food lasted. It means the same thing. Survived on the remaining food. So number of days the soldiers survived on the remaining food. So A, we are considering the number of soldiers, and B, the number of days the soldiers survived on the remaining food. So this is all about the fact after 4 days. So after 4 days, some soldiers were transferred to another fort, and thus the total food lasted for an extra 32 days. Thus the food lasted for an extra 32 days. Okay, extra 32 days. After 1200 soldiers in a fort is supposed had enough food for 28 days. Okay, so that food will last for 28 days if the number of soldiers is 1200. After 4 days, some soldiers were transferred to another fort. Okay, and thus the food lasted for an extra 32 days. An extra 32 days. The food lasted for, after 4 days, some soldiers were transferred to another fort, and thus the food lasted for an extra. These 32 days, is it after 4 days, or is it the total number of days? So after four days, some soldiers were transferred to another fort, and whatever food was remaining, that lasted for an extra 32 days. I mean after 4 days, the food is supposed to be lasting for another 24 days, because it says in the beginning that had 1200 soldiers had enough food to last for 28 days. So after 4 days, the food should last for another 24 days. But since some soldiers were transferred, that food lasted for 32 days. Okay. So the first data we have is 1, 2, 0, 0 soldiers on the, so after 4 days, whatever food was remaining, that should have lasted for 24 days for 1200 soldiers, because it is said that the food is enough to survive 1200 soldiers for 28 days. So after 4 days, the 1200 soldiers is supposed to survive for another 24 days based on the remaining food. Now, so after 4 days, the second data is that after 4 days, some soldiers were transferred, and then after transferring the soldiers, the remaining food lasted for 32 days. 32 days, the remaining food. So let's say X soldiers was served by the remaining food in 32 days. So definitely these X soldiers will be less than 1200, because some soldiers was transferred to another fort. Okay. Now over here we have 1200, 24 is the corresponding data of A1, B1, and over here X, 32 is the corresponding data of A2 and B2. Now, so we are assuming that after 4 days, whatever food is remaining, that food is lasting for 32 days, and it is serving X soldiers. So now we have that 1200 multiplied by 24 should be equal to X into 32. This implies X will be equal to 1200 multiplied by 24 divided by 32. So this is 4, 6, 4, 8, and 4, 2, 4, 300. This is 3. This is 900. So 900 soldiers. After 4 days, 900 soldiers were actually served by the remaining food that lasted for 32 days. So definitely, therefore, soldiers that was transferred was equal to 1200 minus 900. This is 300. So 300 soldiers were transferred. After 4 days, 300 soldiers were transferred. So the number of soldiers became 900, which was served by the remaining food for the next 32 days. Okay. So this brings to the end of solving the exercise 9b. So this question number 9, 12 and 10 was tricky. You have to solve these problems a few more times to understand the concept and how to identify the two quantities A and B, and apply the concept of the inverse proportion, that is the product of the two quantities remains the same. So I hope this video was beneficial to you, and if it is so, then please like it, share it with your friends, and also please support me by subscribing to my channel, and please do not forget to press the bell icon so that you will be notified by my future videos. So the next video will be on solving the MCQ, that is objective questions based on this chapter, unitary method, that is two quantities that vary directly and two quantities that vary inversely. And after that I will solve the test paper 9. So please stay tuned for the upcoming videos, two videos on solving the MCQ and the test paper 9, and that will bring an end to the chapter unitary method. So thanks for watching, and until the next video, take care and bye.